for those that are joining time. You are all very much welcome. I hope that we can get a lot done in this session, and I look forward to your engagement on the chat and the Q&A. With that said, over to you, Zablon. We are not sipping coffee right now, but let us get a good glass of water. Back to you.
All right. Yeah, so to our Kenyan learners, just tell us how your lunch was in the chats. And the ones who are about to have to take their lunch, please just let us know what you're having for lunch, okay? Yes, nice. Allow me to share my presentation slide so that we can start. Okay, I believe it's visible now. There it is. All right. So welcome once more to the database design class, the afternoon session. Yeah, so in the morning, I started off by taking guys through how to do the week 2 assignment. So if you really want to understand how to do the week 2 assignment, I would kindly request that you go through the morning session recording where I've touched everything in detail, like how you're supposed to do, how you're supposed to do the assignment. For this afternoon session, I'll just start and then see how I'll also try to include you when doing the practice, okay? So let's start. So what are you going to learn in this lesson? At the core of this lesson, you're going to learn how to do the following. Number one, you're going to understand what transactions are, database transaction, and their properties. You're also going to group data effectively using the group by clause and filter group use with having for more refined results. We're also going to utilize advanced SQL aggregation function to perform complex data retrieval, including count, sum, average, mean, and max. Later on, we're also going to use SQL commands to filter data in the database. All right. Okay, so I want to open my SQL workbench. Okay. Um, I want to share a link. This link will contain the slides so that I open the presentation slide, and then as I talk to you, you can just review the slides on your own. Believe the slides are visible. There, I've shared. So just access, okay? And then as you access, kindly just open your SQL workbench. So I'll open my SQL workbench. Okay, so right now I'm sharing my SQL workbench. I believe it's the one that is visible. Okay, and in another tab, I'll be reading the slides. Okay, so I'll start. Okay, I believe now you have access to the slides, so you know where I am. Okay, so I'm in page 3 of the slides. Meanwhile, I'll try to sign in here. So if you have your workbench, also sign in and then wait. So let's start. What is a transaction, or what is transaction? So we say transaction is a collection of operations, the reads and writes, that are treated as a single logical operation. Okay. So under transaction, we have the properties. Okay. So the properties are atomicity, consistency, isolation, and durability. Okay. So the initial can be written as ACID, or acid, the acid properties. So let's start with the first one. Or why does a software developer need to understand like the acid properties? Because number one, lots of things could possibly go wrong when using a database. Number one, we say the database hardware might fail, okay, or the software can fail. Also, the application calling the database can fail mid-operation. Another thing that can happen is the network can be flooded with more traffic than it can handle, okay? Another thing is when several people are trying to write the same to the same database at the same time, okay, overwriting each other changes. Okay, so let's start with the first property, atomicity. What exactly is atomicity? So please note this down if you're writing. Okay, so number one, we say atomicity simply means that all queries in a transaction must succeed for transaction to complete. All queries in a transaction must succeed for transaction to complete. If one query fails, the entire transaction fails. What do I mean by this? For example, I know everyone here has purchased something from an online shop, right? A transaction could be when you're trying to add whatever item you're trying to purchase to the cart, and then you finalize with the payment, right? So that's a transaction. So that moment you add it to the cart, and then an order is going to be created when you finalize with payment. But what will happen if you don't make the payment? If the payment has been initialized for you, or you are prompted to make a payment and then you don't make a payment, what's going to happen? So number one, this transaction will fail. Okay. So this means that this transaction will not be completed. Why? Because you did not pay. So what will happen is the order will not be stored where? In the database. Okay. So that's how atomicity can be ensured within a database. So what happened that really causes the need for atomicity? Number one is when you're trying to make some partial updates or power failure. So last week we shared a sales database where you're supposed to import data from a sales database. I believe everyone has access to it. And I said we all open our SQL workbench, right? I believe everyone is in the SQL workbench. So please just react to the thumbs up if you're in the SQL workbench. Please react to the thumbs up or in the chats if you've opened your SQL workbench. And you're with me up to this point where I've said you open your SQL workbench. Now, perfect. So I believe you all have the sample database. I'll import mine because right now I don't have it, okay? I'll take the shortest time to import it because of time. So please don't import it if you already have it. So I'll sign into my terminal. Okay, so I know it's there, so we can verify. Here it is, it's here. So I'm just trying to import the same thing. Write this MySQL -u root -p. Okay, so let's create a database. All right, so allow me to populate it with data. Right now, I know it doesn't have any data, so I'll just refresh. It's empty, okay? So I'll just come here and populate it with the data that I want. And then -p. Okay, you don't need to populate it again. I'm just doing it because I deleted mine by mistake. There. So I'll pass in. Great. We are done. And there are the tables. Okay. So I want us to work with these tables later on. So yeah. Now let's start with by seeing how we can achieve atomicity. So start by writing this. Let's create a new table. So right? Use, if you're using the terminal or the workbench, either can work. So I believe everyone is in their workbench or the terminal. So use salesdb like that. We are all at line 1, okay? So let's create a new table. Let's call this table accounts. Okay, then let's go to the next line. Take a deep breath. We've all written that, right? Okay, so write this. User ID. It's gonna be integer. Also a primary key. Okay. Another thing is what? Okay, we can add a comma. Create new. It's gonna be of integer data type. Yes. Now take the shortest time to write whatever I've just written. We are all set, right? I believe I've waited for everyone. All right. So let's execute. So how did we say we execute? 1, 2, 3. 1, 2, 3. This is where you click and then it's gonna get executed. So once I click here, we're going to see this table that we call. Okay, I'm trying to see if it has already been executed for the output. There it is. So you'll see a green check that says that, and then the amount of time it took. So 0.15 second, okay? So if I refresh, we're going to see the table is here, the accounts, there it is. I believe we are all set. Okay, so once we are done, once we've executed, I said to execute, you click here, 1, 2, 3. Okay, so we've created a table, okay? Right now, the table is empty. So what we want to add some sample data so that we test to this data. At the same time, we want to perform 2 transactions or different transactions. At the same time, we want to update. So to do that, let's test here or insert data. Let me go to a new page for clarity. I'll just copy this. To go to a new page, you click here. Kindly just click here. See where my mouse is. Just see. I said you don't move to your workbench. Okay. Yeah. I'll stick to the workbench until the end. So just remain in the workbench. Here, just see my mouse there when open, and then that's. Now let's go to the next slide. So insert into, okay? We write what? Insert data. Currently our table is empty. So we want to insert some data. And I said to do that, we write insert into, okay? What is the name of the table? It's called accounts. Like that. Open a bracket. Inside here, you specify which column do you want to insert data into. So for our case, we only have 2 columns. It's called the user ID and the balance. Okay, we've already created this table. I said to create this table, you just click here, and then this table will be created for you. and then you refresh here, you're going to see that. And then to maybe open a new working area, you just click here. And now, once you've done that, you start by writing insert into accounts, and then write user ID, comma, balance, close it, take a deep breath. Where am I getting this? It's here, user ID and balance. These are the name of the columns. Go to the next slide. Then, okay, write values, open a bracket. You can also close it, it's okay. So we want to insert data now. So that's the first user ID. And then the balance, we can see the balance is maybe 1,000, okay? We also want to update it such that once the balance has been created, maybe they made a payment or they deducted 100. So we update it automatically again, update. The name of the table is called accounts, okay? And then come to the next line for you to read, to be able to read clear. Set balance equals, okay? Balance minus maybe 100, where, okay? Where user, apologies, it's user ID equals 1, semicolon, and then we finalize with commit. Let's see how atomicity is usually tested. And then we write here at the top, start transaction. Okay, sorry, semicolon. So let's take the shortest seconds to write this. Please react with a thumbs up if you are already done. I'm seeing 2 people, 3. Yeah, if you're not able to follow along, you just write in a small, write in book, in a small piece of paper where you can be able to make a reference later if you're not able to follow along. So, believe we are all set, right? Okay, we've all written that, right? So if I try to update, okay, you'll see the user balance is gonna be saved to be 900. So if I update there, I've executed and reconfirmed, I'm getting the green checks here at the bottom. So if I retrieve this table, let me open a new working area for you guys to understand. You don't need to keep on opening a new working area. You can just work with one, but comment whatever you had already executed. So we've already learned this. So to fetch everything from the table, we write select from accounts. That's the name of the table. Execute. The balance, the user ID 1, their balance is 900. We did 2 things, all at once. We did what? We updated, we inserted, and we also updated all at the same time. Are we together up to this point? Are we together? We did 2 transactions all at once. So what will happen if I insert a new user ID, maybe 2, and then here I'll change to be maybe 500, and then they try to minus 1,000. Also update here. Update the way I'm updating. So right now the values is 2. Okay, the new user ID it's 2, and then the balance is 500, and then we try to minus the actual balance that we've inserted from this. There's something I want you guys to see. And then where the user ID is 2, what will happen if I commit this. I believe we are all in the same pace. Execute. There, as you can see, I've executed. What will happen if I try to fetch again? I get a user with a negative balance. This is wrong. Okay, a user cannot have what? A negative balance. So to avoid this, maybe, let's say, for example, instead of committing fast, we should do what? Roll back. What will happen if I change that to be roll back and then I change here 3 and then they minus the same thing? You'll see, instead of this one being saved, what will happen? Execute, okay. Take the shortest time to update yours. We are all set. All right, cool. Now, if I execute, there, you can see the rollback was successful. Let's try to fetch. Do we have it? No, we don't. What just happened? Here, in this one, what you call atomicity was achieved. Do you guys now understand the point when I was telling you, for example, you try to purchase something from Jumia and then you don't initiate the payment, what will happen? I believe we are all together on that. Have you all understood the atomicity point? So we said, I've shared presentation slide, just look for the link. I said, what did we say? Please, if you know you've written and you have the notes, please tell us in the chat what atomicity is for those who came in late. So we said atomicity simply means that all queries in a transaction must succeed for a transaction to complete. If one query fails, the entire transaction fails. We've actually confirmed that this one failed, right? So this means this one could not be inserted. The entire transaction failed. Okay. So this means we're trying to see how atomicity is achieved when inserting maybe something inside a table. And I used a very simple example to bring the point home. We started by inserting a user account balance. And I said we can do that by just updating, trying to see if we can be able to update with 2 transactions like quickly, and then see what will happen if you see maybe something is not like adding up. For example, when I committed, the user had what? A negative balance. And you know, this one cannot be true. You cannot have a negative balance. Okay. So to rectify this, we had to ensure we roll back in case there's an error with our command or whatever we're trying to execute is not making sense, we roll back, meaning that will not be saved. The same way, when purchasing something from an e-commerce site and you're trying to add the items in the cart, and then when you initiate the payment, you don't make the payment, whatever you are trying to buy will not be saved or will not be added to the orders table of that e-commerce site. That one is clear. Let's go to consistency. You have the slides. Now, with consistency, consistency ensures that a transaction takes a database from one consistent state to another. I'll repeat. Consistency ensures that a transaction takes a database from one consistent state to another. So let's do a practical example because I haven't moved from I haven't moved from the workbench, so I believe no one has moved from their workbench. Okay. Now, let's try to create a users table. We are all set with this one, right? So I'll remove everything. I'll just clear everything. And then I'll write here, users table. Okay. Now come to the next slide. Say create table. Okay. We are trying to see how consistency is achieved within a database. And I've said with consistency, it takes it ensures that the database moves from one state to another. So the name of this table is called users. Open a bracket, go to the next slide. So what are some of the columns that we want? Number one, we can try with user ID. So what data type will this user ID be? It's going to be an integer, okay? Also, we can pass another constraint called a primary key. Why? Because we want to use this field to uniquely identify other rows. Now, when you write that, put a comma, go to the next slide. And then write username, varchar, say there 100. We can say we only want unique usernames, like that. Let's go to the next one, email. Also varchar 100, also unique. Another thing we can store is age. We only want to store users who are above 18 years of age, okay? So we can say age should be above 18 years, like that. Any other? Okay, that's it. We can just close it like that. So, believe everyone has written whatever I've written. If you're noting down, please note. If you are writing in SQL Workbench, right? So again, to execute 1, 2, 3. So it doesn't mean that you need to just use the workbench. Maybe if you feel you're comfortable with the terminal, just come and do it on your terminal. Okay. Yeah. So once I execute, this users table will be created. So how do we execute? 1, 2, 3. Execute there. So if I refresh, I'll see the users table. There it is. Currently it's empty. So let's try to insert some data here, and then I'll just copy this one. So I'll write insert into, what is the name of the table? It's called users, right? So what are some of the columns are we trying to store data into? Let's come back here. The user ID, right? We have the username. We also have the email and the age. So please go and write that. So I'll just come and copy mine. I like making things simple, comma, and then also this, comma, paste it, then comma. Another one we can store is email, paste it, comma. Finally, we have age. And you see, the things that have added, okay, after adding the data, we call it constraint. This is a constraint, this is a constraint, this is a constraint, this is a constraint. Why do we need a constraint? Because we want to ensure data integrity. Our data is not what? Corrupted. We are clear on that one. Okay. So yeah, if you are with me, I believe you've already started inserting some data. Okay. Close it. Come to the next line, right? But you know, you don't need to keep on coming to the next line. You can write it in one line, but for easy reading, just come to the next line. Okay. So write values, open a bracket. Now write 1, comma, username is a variant char of data type, right? So I can write here maybe Simi, okay? And then Simi's email is simi@mail.com, right? Maybe Simi, let's try to pass Simi's age. She's 18. Will this one be stored? Let's confirm. If we execute, okay, we get what? User check is violated. Do you see, guys? Do you see this error? This one on line 27. Okay, I know yours won't be number 27, but are you guys seeing this error that I'm getting? Check constraint, because we violated 1. Okay, so this means it's not consistent because we said here this should be above, unless we added equal to. That's when we are able to show people who are starting from 18, going forward 19, 20, up to 100, up to 1,000. I don't know if is anyone with 1,000 of years. But since we only said we only want people with only whose age is above 18 years, that's why we are getting this error. That means, you see, we are trying to need to corrupt our data. Okay, that means this data will not be stored. So the DBMS will ensure that integrity is not violated. That's why it will throw this error. Are we together on that? How consistency is usually achieved when inserting anything on the data? We've covered 2 points, atomicity and consistency, and we've confirmed how it is usually done, right? Let's go to isolation. I believe I'm clear on that one. So yeah, still on the presentation slide, I'm on page 3. Okay, I haven't moved. Now, isolation, write this down or not somewhere. Isolation means it guarantees that concurrently running transaction should not interfere with each other, such that, okay, it refers to 2 or more transactions to trying to modify the same database at the same time. Okay, so write this down. Isolation refers when 2 or more transactions are trying to modify or read the same database record at the same time. Let me come back. I don't know if I'll be able to get. Okay, yes. So coming back here, guys, do you remember this when we started the start transaction, right? We were trying to execute 2 things at the same time, right? So what we did, we were trying to execute 2 transactions at the same time. And we saw that when adding rollback, it ensured that atomicity is not violated, right? Where the data was not stored because it was fake, where we were storing a negative balance, okay, which should not be like that in real world. So to enforce what we call isolation, you simply come and append here. Okay, I'll need to change this. Let me just allow me to change here, maybe for they are minusing 100 also here. So please take the shortest time to update according to what I've just done. And then add this at the top of transaction. Write this. Level transaction isolation level read committed. Allow me to move something here on my screen. Like that, semicolon. Okay, it's very long. I hope if I zoom out, you'll see. Is it visible? Please react with a thumbs up if you are able to see. So set session transaction isolation level read committed. Is it visible on your end? Okay, perfect. And then change here to committed. Commit, not committed. Yeah, like that. So we've all written, right? Set session transaction isolation level read committed. And then line 4, we started by writing start transaction, insert into the name of our table is called accounts, and then the user ID, the balance we are trying to insert, and also the update that we're trying to make, okay, simultaneously. And then where the user is that, and then whatever change we make, we commit, meaning that it will be stored. Once I execute, we get all that. And then as you can see, getting green check. If I try to retrieve, what will I get? We get 4400. So we are all at par, right? We are all together, right? Are we together? All right, cool. Impressive. So
Hi, Zablon.
yes, Gerald.
Please check the chart kindly.
Yeah. I've seen it. Thank you. All right, perfect, Gerald. Now, uh, now go to your slides in page 4. So if you want to see the isolation, how the isolation thing is written, it's here. So just write this and then try to see if it's executed. And you can move to the next slide where we have the aggregate functions. But before we come to the aggregate function, I forgot to mention some of the benefit of why we need the transaction. So number one, the importance of ACID properties, we can say it ensures data consistency and integrity throughout transactional process. Okay. Number two, it prevents data corruption by maintaining atomicity. Okay. Also, it guarantees committed transactions are permanently saved, ensuring data durability. Are we all together? Yes. Now, let's learn about the aggregate function and what they are. So we say an aggregate function is a function that performs a calculation on a set of values and returns a single value. Okay. So go to page 4 on the slides that I've shared. So an aggregate function is what? The function that performs a calculation on a set of values and returns a single values. We are together up to that point. So what are some of the common aggregate functions that we have? Number one, we can say we have the count, sum, max, average, and mean. So what is the function of mean? Write this down. So with mean, it returns the smallest value within the selected column. Okay. So we say mean function or mean method returns the smallest value within a selected column. So mean returns the smallest value within the selected column. Max return the largest value within a selected column. Count returns the number of rows in a set. Count returns the number of rows, just write that. Count returns the number of rows, okay? It returns only the number of rows. That's the work of count. Now, let's go to sum, right? Sum returns the total sum of numerical column, okay? Sum returns the total sum of numerical column. Sum returns the total sum of numerical column. Sum returns the total sum of numerical column. We also have average. What's the function of average? It returns the average of a numerical column. Okay? We good on that? Are we all together? Yeah, react with a thumbs up. Perfect. So go to the next slide, slide 6, where we have the group by clause. So group by clause groups the group by clause groups rows into a summary row based on column values or expression. Okay. So you can see how you can combine the group by with the aggregate function, and then we write the commands. So we haven't started writing doing the practical part of the group by. So we just learned the theory and then we touch on the group by and the halving. So with the group by, summarize it into this. It groups rows that have the same values into summary row. I'll repeat. The group by groups rows that have the same value into summary row. It groups what? The rows that have the same value into a summary row. Okay, so come back to our workbench. I can clear this or I can just leave it that. Let's clear this. Now we write something. Write this. Okay, it's a question, but try the, okay, you can try and then tell me what you're going to get. So, write a query. Let me add it in form of multiple lines. Write a query to group order status. Okay, from the orders table. Let's try to solve this. Okay, you don't need to write the question. I just want you to understand what you're doing. So write a query to group the order status from the orders table. Where can I get this orders table? Remember the data we imported? The orders table is here. So if we fetch, select everything from, okay, the orders like that. If I execute, what will happen? We're going to see everything. So our main attention is where? Here in the status, okay? As you can see, we have cancel, 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 in progress, on hold, all that. Those are the asking where to get this table. I said this table is inside the data you imported. So when you open this database that you just imported with tables, you'll see it has the orders here. And then you write this question. Write a query to group order status from the orders table. So before we tackle the question, let's try to retrieve everything from that table. We see, does it have that column that we trying to understand, the status? We can see we have shipped, shipped, shipped. There are so many, resolved, cancelled. So what we want to do, okay, essentially is to just group all these that we get the number of orders that have been shipped, also the numbers of orders that have been cancelled, the numbers of orders that are in progress. So how do we do that? Come and write here, select status, like that, group by status, and then you execute. What will you get? All that. So you can write that and then tell me what you're seeing on your end. Yeah, the ones who are asking why yours doesn't have accounts table, that means you're either late or you're not listening when I said, let's create a table when you're starting to understand the ACID properties. Right now we're in the group by. I shared a link for the slides. So once you select status from orders and then you group by status, this is what you're going to see. Because we've grouped all of them. There are so many occurrences where they were grouping, they were repeating themselves. You could see that like there are multiple occurrences of ship, ship, shipped. So instead of having all that, we can just group it into one. We get only one value. Shipped, resolved, cancelled, on hold, status, dispute. This is just an example. Let's write another example. I'll open a new working area. I'll just need to copy this. Don't have to write. Don't feel like writing a lot like that. Let's see if we can tackle our second question. So one thing to note is, in practice, you often use the group by clause with the aggregate function to group rows into sets and return a single value of each group. For example, to obtain the number of orders in each status, you can use the count function with a group by. So uh, we want to group the number of orders, right? In each status. So how do we write this? Okay, so come here to the next line and then write the left. Okay, so you can even start by selecting which one? Order number. Those who are wondering where I'm getting this column, these columns are here. If you come to this table, there is the order number, right? We also want to work with the status and then get to understand how many occurrences are there that are written cancelled. So that's what we are trying to achieve out of this question. And then comma, then write count of everything from, okay, what's the name of the table? Orders. Go to the next line, group by the order number. Forgot to write something there. Order number, like that. You can also add another one, status, and then also add status here. Okay, so if you execute this, there we have it. So you can see the number of shipped was 111. So let's try to clean this. Instead of having that, remove this, remain with only that, and then try to get all of them all at once. So you can see the number of shipped was 303. Number of orders that were shipped was 303. Resolved was 4. Cancelled is 6 from the entire table. And then on hold is 4. Disputed is 3. What do I mean by this? You see, when you open the entire of this table, you see there are so many occurrences of cancel, cancel, cancel. So we are counting all of them. Okay, that's why we're getting these numbers here. Are we together up to that point? Now, instead of having it as count here, the title, I just wanted to make the title be more appealing for someone to understand clear. So we, in database, we usually have an alias. An alias just like a nickname, okay? Temporarily, a temporal, how do I put it? It's like a nickname, okay? Yes, it will not be stored permanently, just for a short period of time. So I can write as number of orders, like that. If I execute, there it will appear number of orders. So yeah, this is just a temporary name. Okay. Yeah. So please write if you're writing. Once you're done, please just react to the thumbs up if you're done so that I know we've all done, we are all done. So I can continue. We are all set, right? So the other question we can tackle is, let's see if we can tackle this. Okay, open that. Believe we all have this data, right? Where am I getting all these tables from? This table is, remember if you went through the lesson recording, okay, and you did a week 2 assignment, I gave you guys a sample database, right? So that sample database is the one that we are working with, okay? So come to the next slide, okay? Let's tackle a new challenge. Or we can even open a new, which one? Payments. Let's see payments. Payments has this column, has the amount, has the check number, has the payment, date, and all that, okay? So we can try to group all these and see what we'll get. So start by writing this kindly. Get a new working area. If you're all set, kindly let me know. Okay, let's write. So I say it again. So which command do we use when you want to retrieve? Let me know in the chat. Which commands do we use when you want to retrieve maybe a particular column? Which command did we say we use? Select, right? Now you start by writing that. Select, right? This is the command, right? We've written. Has everyone written this? Select, the ones who are following along. If you're noting down, just note select, write that. And then we said, we want to retrieve a specific column, okay? So the reason why I gave you sample database is because to save on time, okay, when creating this table, I want you to work with a table that has a lot of data so that you get to experience and see how it works. Because now, if I start creating this table, it will take me around maybe 40 minutes before I insert all this. Okay, so we want to retrieve maybe this column. So how do we write? You come back to where you are writing, and then write the way it is. It's written as how? Check number. So why don't you just come and write here? Check number, like that, comma. Then the next thing is check which column do we want to aggregate. Maybe you want to aggregate the amount. Come back here, right? Sum amount, like that. And then you specify from which table do you want to work with. What's the name of the table? Please mention it in the charts. What's the name of the table that you're working with? The name of the table is called payments, right? So we write from. That's the name of the table, payments. Okay, go to the next slide. And then write group by, okay? For you to group by, you're only required to group by the column that is not being aggregated. You see this other one, you cannot group by this one. You only group by the one that you're not what? Aggregating. Okay, you add it there. And then semicolon. Why do we add semicolon? Because we want to tell the server when executing that all this command ends at this. So if you execute from the top, what will you get? You'll get all this. So this check number is the amount they paid. This check number is the amount they paid, and all these other check numbers. For example, another thing we can add, let's remove the semicolon. We can add what we call a halving clause to get only the amount. So here I'll need to pass what you call an alias to get the name of this column, to just pass a temporary name, okay? So let's write here as AMT, okay? Having an amount, maybe we only want to see only the check number having an amount greater than maybe 10,000, like that. If I execute, what will happen? We are only going to see only those check numbers that have an amount. Okay, when you aggregate their sum, you'll get 10,000 and above. So you not see anything below 10,000. I believe this is visible, right? So please write this if you're writing down. Once you're done, let me know. Yeah, if you're done, just let me know in the chats if you're done. All right. Yeah. So once you execute, you'll get all these, right? Now, let's try again with another example. Yeah, oh, by the way, you can always change this. Maybe you can even try with the less than sign. Okay. We say these are what? Comparison operator. And remember in our week one, lesson one or week one class, we started by comparing what you call the logical operators and the comparison operator. So to get an effective output, just work with the comparison operator, maybe the less than sign, the equality, what you get. You see there's none that is equal to 10,000. Maybe let's try with 20. I don't think we have, but let's execute there. So yeah, okay. Anything less than or equal to that, let's see. There we're getting 615, 3,452, all that until 9,501. Okay, 0.82. That is the one that is closest to 20,000. So the next thing, go to the slide, the next page slide, the halving clause. So the halving clause is used with a group by. Okay, I know I introduced, but I didn't say what it is used for, its function. Okay, the halving clause is used with a group by clause to filter the groups based on a specified condition, okay? So the condition here was, I only want the amounts that are less than 20,000, okay? That is what we mean by having a condition or specifying a condition. Okay. Yeah, so the next point want to pass is where? Let me see. Are we all clear on the having clause? All right, cool. So if you're all clear on that one, let's go to page 9. I need one volunteer to read for us. One volunteer. Let's go with Abdi Hakim. No, Abdi.
I read number
Just
9.
read for us. No, read for us the checkpoint question. Yes, yes, please.
Slide 9.
Yeah.
Checkpoint questions. Number 1, explain what durability means in the acid properties, ACID.
Yeah, we've already covered on durability. Okay, so durability is when you want to save all the data in the database. Okay, so yeah, explain the durability part. So let me read some of your comments in the chat. Go to the next one. Abdi.
I continue.
Question 2. Yes, yes, please.
What is the purpose of the group by clause in SQL? What is the
Right.
purpose of group by clause in SQL?
Okay, so what is the function of the group by clause? So we said with group by, it does what? Group by, it does what? Let me see the ones who are typing the answers. Thank you, Mary. It says to group rows. Yeah, that's perfect. Question 4. No, 3.
Explain the difference between the where and having clauses in SQL. When should you use each?
So guys, what's the difference between where and having? So Evelyn says where is used for all, and then having used with a group by. Perfect. Evelyn was there. Yeah, true. So with the having is only used the group by. You cannot use it anywhere else. And then the where, you can use it anywhere. So final question, Abdi.
Explain what an engagement function is and provide at least 3 examples of aggregate functions used in SQL.
Impressive. So we said we have various we have various aggregate function, right? I only touched on around 2, right? So maybe you can even try with average. What will happen if I change here to average? Okay, there. So we're getting the average. That's why you see it has so many zeros. What if I change here? Let me try to improve this one. Instead of having let's get the max amount. Okay, there. So we have the max amount within this check number. Okay, if there's any other occurrence that has this check number BN 17870, maybe there are two. Maybe the other one has 2,000, and then this one has 3,000. It will pick this one because here I've specified as max. Another way we can use max is, for example, let me open the order. Maybe you want to get in this, which one? Do you have any amount here? No. Let's go with order details. If you open order details and you check the price of each, right? So maybe you want to see what is the maximum, okay, or the highest number of ordered orders that were made. You can use the max function to get, okay. Right now it's taking too much time to see, but if you actually wrote right here, use the name of the database is that, okay, and then select, okay, we can say order number, and then comma sum quantity multiply by the price of each, close that, okay, and then say an alias as total. Come to the next line, okay, say from where? From the name of the table is called order detail. Group by, okay, so allow me to minimize this. Group by order number. If I execute, I'll get an error. Let me see the error. Okay, it's saying a non-column order number. So I missed, there's a misspelling there. Okay, there's also another one. Okay, we see a non-column quantity. So it's quantity, it was what? Let me see. Keep forgetting the name of these columns. It's supposed to be quantity order. There it is. So let's try to execute. There we have. So you can see this one, this is the total amount they paid. What if we change? Okay, let's just leave it like that. There it is. So can work with that, can get the minimum, the maximum, and so on. Yeah, so while at it, Abdi, read for us the key takeaways. Abdi?
Yes. The key takeaways. Number one, the group by clause is used to group rows that have the same values in specific columns into summary rows. I continue?
Yes, please.
Okay, number two, the having clause is used to filter the results after the group by operation. Three, durability ensures that once a transaction is committed, its changes are permanent even if the system crashes, preserving data integrity. Number four, it says isolation ensures that multiple transactions can occur concurrently without leading to the inconsistency of the database state. Number five, consistency ensures that a database remains in a valid state before and after a transaction. Number six, atomicity simply means that all queries in a transaction must succeed for the transaction to succeed. Was I clear? Hello?
Yeah, Mr. Abdi,
I was clear?
thank you so much. Yes, you're very clear. Let's all
Thank you.
clap for Mr. Abdi. React to the thumbs up. Okay, not the thumbs up. Clap. Please clap for him. He has really done an amazing job. Yes. Now, I'm gonna share a part of my screen. Please allow me to share a different section of the screen. I believe from the link that I shared yesterday, we all installed Node.js, right? Okay, how many of you have Node.js installed? So that I try to see if we can do the next thing. How many of you have Node.js installed? How many? Okay, so now for the next one, because I can see quite a majority of you don't have Node.js. So this is what I'm gonna do. Please allow me to just work on it. I'll try to be as slow as possible on this one. So I'm gonna share this lab, okay? So this lab, you can do it at your own free time. It's not compulsory. It's only if you only want to complement whatever you've learned during these 3 weeks to just add on top, okay? And see how you can use the database together with other programming languages. So if I share, and then you see this link, let me share this link. Come and copy the lab down. Okay, clone this lab, okay? I'll show you how to test all these because we still have a lot of time. So I've shared the link. But if you don't have Node.js, just watch kindly and then pay attention to what I'll be doing, okay? If you want to do it later on your free time. But again, as I said, it's not compulsory, it's just something to complement your knowledge, okay? So first things first, come and copy here and then copy the link, right? So remember, in week 1, we started by learning what? How to create a database, right? Week 2, we learned about DDL and the DML. So we said DDL brings what? Database object into existence using the create and the lights, right? Now with DML, we use it to do what? To insert data, to query and things like that. So first things first, what you are required to do to run this locally. So this is a simple CRUD that enables you to create, read, update, delete API built using Node.js. This API allows users to perform basic operation on a library database, such as adding a new book, viewing an existing book, updating a book, and deleting a book. So features, you'll be able to create a new book entry, retrieve all book entry or by book ID, update books, okay, or book detail, delete a book from library. So to test this, okay, so everything has been written for you, okay, so including the packages. So what you are required to do is access, I'll open again my CMD. Believe that is visible on everyone, right? So we said you change to a favorite location of yours, okay, where you prefer having all your projects. And that's what me, I like having them under desktop. If you prefer downloads, go there. If you prefer anyone else, go there. So I'll clone this, git clone, then paste the link. Okay, where did I get this link? I copied from GitHub. Now, the name of this repo is called what? Lab4. So change directory into lab4 like that, press enter, then clear the screen. Okay. So the next step is to install the dependencies. How do you do that? If you have Node.js already installed, npm I. Where am I getting all these commands? To get these commands, they are written here. So cd lab4 npm install, and then start the server like that. Now, press I like that. So as you can see, it has already completed installing all these packages, around 110, 111. So, but before we start the server, let's create the database. Okay, come back to here. Okay, don't worry. I know majority don't have Node.js, so you'll just watch the recording once you install the Node.js. So let's create a new database. Where do you get those commands? They are here. Create database library, come and copy. So we've made this easy. Your work is just come and copy, put it into test. Once you execute, refresh, there is our library. Currently it's empty. Now let's try again here, copy that, come and paste it like that. Believe it's clear, execute. There, once I refresh, there is our books table. Currently it's empty, doesn't have anything. ID, title, description, cover. It's currently empty, doesn't have anything. So we've created the database and then we've created the table, just those two. Because I said this is something very simple, just to complement your knowledge. Now, come back to your terminal, okay? Write code dot. Why do we write this? Because we want to open what? Visual Studio Code, okay? So once you do that, access this file that's called index.js. And then go to line 13 where you're required to add your password. So I'll put my password. If yours is 1234, this is where you write it. Pass 123. Okay, that's my password. So here we're trying to initiate what you call a connection, okay, to see if this project is able to access the database. Then when you target this endpoint, okay, here you're trying to fetch all books that are currently in the books table. Okay. So once you do this, okay, where am I getting this? So these commands or this code, you're going to be taught them in the web development class. Okay, I understand right now you're still new, okay, but don't focus so much on this code because you're going to be taught what they actually do. So what I want you to put emphasis on is here. You see where I've written like const query, okay? I'm creating a variable. You see these commands like this one, select all from books. This is something that you've already done, right? Do we all agree? Okay. So come to this other one, they select all from books where that, okay? And the other one is insert into that, okay? So once you add your password and then when you hit this endpoint, you're going to fetch all books from the books table. The other one is when you want to fetch for a particular book, instead of retrieving maybe you want to see which book is in the library, you're going to hit this endpoint. I'm going to show you how you hit these endpoints. Now, the other one is to add a new book. Okay, when I hit this endpoint, I'm going to insert into, okay, as you can see, this one you've all read, right? Insert into title, description, cover. And then this one's for updating, and then this one's for deleting. So to put this into test, number one, come to the extensions, okay, and then look for what is called Thunder Client. Now this one, then click here, install. Okay, so once you install, this is how it looks. Okay, and then click new request. All right, we're all together. Now, once you click new request, come back to your GitHub, okay? And then copy this, okay? So the first endpoint that you're trying to hit is what? Fetch all books from, okay, let's not start with this one. Let's start with adding a new book. Add a new book. Use to create a new book entry in a library. Add books, detail that in the request body. Okay, you're going to be taught what we mean by when you say request. Request is when it wants to take in the data, and then there's what you call response. All this will be taught in the web classes. Okay, so copy this. So we've made it easier for you just to come and copy. Okay, and then come here, paste it. And then instead of having the post here, because I wanted you to get to see how what you are required to change. Click this drop down and then select post. So post that endpoint. So this is what we call an endpoint. An endpoint is just a URL path. Come to the body and then open what you call, we want to pass what you call JSON data. Why? Because JSON is what you call data interchange format. So we want to pass in the title. Okay, where am I getting this? It's here. Remember when you created the table, it's here. The title, the description, and the cover. So let's pass them. So the title, maybe I'll choose okay. So the name of the book, maybe Who Moved My Cheese? And then comma. Another so description. I won't write an actual description. We'll just write some gibberish. And then comma. And then the cover. Okay. No. Okay, so if I execute, please pay attention what will happen. Now, this is what we say, okay? This is a request body. If I send it, okay? The reason why I'm seeing this is because I did not start the server. So I needed to run this npm start. Then you'll get this. Now the server has been connected to the database, so we are good to go. If I hit the endpoint again, there, so you see book has been created successfully. If I try to fetch, will I see the same thing inside my database? I'll try again. So as you can see, we are seeing Who Moved My Cheese, there, cheese, and test PNG. So Node.js is communicating with our server, and then that data is being stored where? In the database. This is how now I'm starting to introduce into the concept of backend. This is how the backend works, okay? But this is something very, very simple. Now, let's create a new one. We can create another one. Let me call this one outliers. Another book. I want to show you guys what will happen. So we've created 3 books instance, right? So if I come here, will my record be the same? Let's retrieve. There they are. Outliers, Who Moved My Cheese, Death Row. So for example, maybe I've made a mistake. This one maybe should not be Death Row. So what will I do? What will I do? I'll click this drop down, pass, put. Where am I getting this? Here. To update an existing book, you use put. Use to update the details of an existing book by its ID. So if, for instance, we want to update book number 3, okay? The book number 3 is called what? Death Row. To do that, come back to Visual Studio Code. So add / and then write 3. So instead of the Death Row, okay, let's write maybe the psychology of man. Like that. Okay. Try. And then we get book has been updated successfully. Let's confirm. Is this true? If I execute here again, it turns what? The psychology of money. Are we understanding? Okay. Now, if I try to fetch everything, so to fetch everything, where is that? We use what? This one, fetch all books. If I execute that, remove that, and then to fetch everything, we use the get. If I retrieve, I'll get what? Everything, but now in what? JSON format. Okay, so who moved my cheese is there, outliers, the psychology of money. Okay, do you see now how the front end reads data from database using the JSON? So what if I want a single occurrence of just a single occurrence of the book? Okay. Oh, I forgot to tell you, when you're making a fetch, you don't need the JSON, or you don't need to pass any data, a request. So as you can see here, I'm fetching and I'm getting the same. So you don't need to pass anything here. So the JSON should be empty. What if I want just a single occurrence? Maybe I want book number 2 to get to understand the details of book number 2. If I hit, I get what? Outliers, just PNG, that's the description. So book details have been fetched. Okay, this is how you can create maybe a simple library management system. Slowly, maybe it doesn't have to books management system, it can be employee management system, staff management system, leave management system, things like that, using the CRUD operation. What we taught you in week 1 and week 2. Have we all understood? I believe we're all together. So yeah, to delete, we also click this and then select that. What will happen if I delete the outliers book? If they're over, okay? So I've deleted, right? Let's confirm, is it still there? If I execute, we can no longer see it. So where can you get all these endpoints? They are here, I've written for you. So what you're required is just to select the dropdown and select input. If select the dropdown and select delete if you're testing any endpoint. So yeah, so you can either use Postman or Thunder Client. Another thing I wanted to take you through is the train booking. So we said, let's create, I want to see some of you how you write some of these commands. And I wanted to bring what you call collaboration in this department so that we work together. So I decided to create a simple train booking open source where and then I opened a few issues. So, this issue has already been filled. Apologies, guys, my afternoon, guys. So, but you can just go through to understand how these issues are being created. And then if you're able to tackle them, you can just try them on your own, okay? So as you can see, these are the list of users who would like to tackle this. We're going to update you next week on how it goes. Thank you so much, guys, for listening to me. I'd like to stop the recording here so that I take in question. I know you have a lot of questions, so as now taking your question.